Hello, my name is Shobna Fletcher. I'm a maths graduate, previously head of maths in a general further education college and a regional maths lead for the Centres for Excellence in Maths programme, otherwise known as CfEM. This is a short video to introduce the bar model intervention. When CfEM first started, there was consultation with the sector, which led to the development of 5 key principles of mastery teaching in further education. These are listed here for you to read. This intervention touches on each of the 5 key principles, but overall we'll focus on key principles 1, 3, and 4. Action research findings over the past 3 years have led to the emergence of 3 big questions. Take a moment to read them inside the circles. It's the question in the green circle: how can we develop learners' deeper understanding, reasoning, and problem-solving skills? That's the most pertinent to this intervention. The intervention is being run by a CfEM college that I've been working with over the last 3 years, Christ the King Sixth Form in London, and is being led by their excellent centre lead, Tumai Gunders. I'm going to hand over to Tumai, who will provide some background for you.
Hello and welcome. My name is Tumai Gunders and I'm an assistant principal and centre lead at Christ the King Sixth Form College in London. This is a short video to introduce you to scaled-up research we are doing on bar models. CPA, or Concrete Pictorial Abstract, as it is commonly known, is based on the work of Jerome Bruner. In 1966, Jerome Bruner postulated that for learners to move into the abstract, they must first move through a series of experience to see the problem with concrete materials and to manipulate them to form some sort of model of the problem. Learners then move on to be able to create physical and mental images from physical explorations, which is called the pictorial stage. Evidence indicates that rushing the pictorial stage, or worse still, skipping them completely, can lead to huge problems of memorization of different algorithms which make no sense. This intervention spends time in the pictorial stage and allows learners to explore. There are a few definitions out there, but at CfEM, we would say that bar models are a visual way to make sense of information in a mathematical problem in order to find out which calculation to perform to find a solution. They provide a way into some AO3 type problems which students may have never attempted before. Bar models should definitely appeal to our arty students, but we do hope that all students can draw a bar and division lines within them. Bar models have been found to be visually useful in the following areas of the GCSE curriculum: fractions of amounts, ratio notation, interpreting ratios, adding, subtracting, multiplying, dividing fractions, ordering fractions, exact percentages of amounts, multiples of 2, 5, and 10, reducing a ratio to its simplest form, dividing a ratio. As some of you may never have used them before, we have picked 3 specific areas to target for our scaled-up research: fractions of amounts, ratio notation and interpreting ratios, and dividing ratios. All 4 activities should take no longer than 2.5 hours in total, and the aim is to encourage learners to draw, sketch, and doodle. Here our focus provides a greater emphasis and importance to drawings rather than the calculations, and also on students being able to reason and explain. Bar models will not help students perform the calculation themselves. This is down to provision, practice, and fluency.
Thanks, Tumai. A bar model is a visual way to make sense of information in a mathematics problem in order to find out which calculations to use and hopefully find a solution. In this intervention, we use both the discrete model and also continuous bars to represent a whole. In the intervention, we also explore the part-whole relationships and how parts of a whole in the same proportion can scale up and scale down. So I'm now going to hand over to Tumai, who will give you an outline of the types of questions you will use in this intervention, but full details will be provided in training.
I'm now going to go through the PowerPoint presentation that supports the delivery of these lessons within your classroom. Please remember that with this intervention and with this scaled up research, there will be CPD running alongside this PowerPoint that will train you up into how to deliver this in the classroom. So activity 1 focuses on fractions of an amount, including fractions greater than 1. This is a key stage 1 topic, as many of us know, and many grade 3s can already do this abstractly. The context chosen is a baguette which forms into a bar model, which we found was easily comparable and engaged our learners. For fractions of amount, learners often use the algorithm. We've all heard it before: divide by the bottom, times by the top. But on the new GCSE specification, questions around understanding come into play. For example, if 3/4 of the number is 30, what is the number? This requires greater conceptual understanding, and if this is mastered, allows them to access a number of topics with a bar model on a non-calculator paper, for example, reverse percentages. Moving on to activity 2, which focuses more on finding the whole given a fraction, as the example I just gave you earlier. In activity 2, learners are asked to find whole from a fraction. The context has been chosen to be engaging to 16 to 18-year-olds, and it's all about throwing a frisbee or splitting up a pie or a cupcake. We've all seen these recipe questions before in the GCSE exam. Activity 3, which is on ratio notation and interpreting ratios, this builds on the fractions of amount representation. Ratio notation is introduced in card sort grouping activity. It explored what proportion and proportion mean and bring in ratio notation. The card sort can be adaptive for your groups, but it was found to be challenging and will require a good 20 minutes. Lastly, activity 4, dividing a ratio. Dividing a number by a ratio using bar models is challenging, as most will revert to using the algorithm to add up the number of parts and divide by the number. You could, if you have them, also use manipulatives for this, but they are not necessary. For example, like coups and air rods. If you've got them in the classroom, that's great. If not, don't panic. Here, we really want to show that the algorithm fails learners for particular questions on the GC paper. This resource was used by Western College and Leighton Sixth Form College last year.
So that's a very quick look at the bar model intervention. Just to add, there'll also be a very short pre and post questionnaire and a few GCSE questions to see if this intervention made a difference in just 4 weeks. We're so excited to share this with you. And finally, it's over to Tumai.
So that's it. In just 2.5 hours, your students will be introduced to bar models in 4 short activities. Will bar models help? According to our research, they might. I hope you found the session useful and look forward to you joining us with scaling up this research nationally.